Today our lesson is going to be how to solve a system of linear equations using the graphing method. So a system of linear equations, or simply a linear system, consists of two or more linear equations with the same variables. A solution of the system of linear equations in two variables is an ordered pair that satisfies each equation in the system. So let's assume that we're using the variables x and y. Then our solution would be the ordered pair x, y. And typically we use this because we're the most familiar with graphing with the coordinate plane, and we typically use an x and y axis. Now, once we get a solution, we want to check to make sure that solution is indeed a solution to both of the equations, which means we're going to substitute in the value for x and y that we've gotten and make sure both of those equations make sense. It's really important to do this because if you just graphed one of the equations wrong, they're going to intersect in the wrong spot and you're going to have the wrong answer. So if you know how to check your solution, you'll know if you made a mistake and you need to go back and check your work. So the first example here, we're going to use the 4 as our x and the 1 as our y. So to check the first equation, I'm going to have 4 plus 2 times 1 equals 6. Of course, 2 times 1 is 2, and 4 plus 2 does equal 6, so you can see that that works. For the second one, I'm going to plug in the 4 for x again, the 1 for the y. We can see that we end up with 12 plus 1, which equals 13, and that does not equal 11. So even though it worked for the first equation, it didn't work for the second, so this one would not be a solution. Now, if we try example 2, I'm going to put in the negative 2 for the x, and then I'm going to put in that positive 1 for the y. So 5 times negative 2 is negative 10, 2 times 1 is 2, and negative 10 minus 2 does equal negative 12, so this equation, the solution works. Now when we go to check the second one here, we're putting in a negative 2 for the x, a positive 1 for the y. I have negative 2 plus 3, which does equal 1, and we notice it works there as well. So for number 2, this would be a solution because it worked for both. Whereas in number 1, the 0.41 is not a solution for the system because it only worked for one equation and not the other. So let's try a couple more of these. Okay, so for number 3, we're going to put in the 4 for the x and the negative 3 for the y. So we have negative 12 and minus 6, or plus a negative, which is the same thing. And you end up with negative 18 equals negative 18, which of course works. For the next one, we have 6 times 4 minus negative 3. Now remember, when you subtract a negative, you're really adding there. So again, we get this one to work as well. Okay, going on to the next one. So this time we have 3 times negative 4 minus a negative 6. Once again, when we subtract a negative, that changes to an addition. Now this time we end up with negative 6 equals 6. That is not true. Now because we already got it to not work here, you could just stop and say, okay, I'm not going to continue with this problem at this point. Because it doesn't matter if it works for the second equation or not, it already doesn't work for the first, so you know that that's not the solution. All right, so let's check another one. So this one here, we're going to put in the negative 4 for the x, the 3 for the y. We have negative 16 plus 9, which equals negative 7. And that clearly does not equal negative 12, so we don't really need to take it any further. And then finally, number 6, we have a negative 2. Be careful here because the x variable is negative, and then we're substituting a negative number in there. So you have to make sure you account for both of those negatives. Now, when you have a negative times a negative, that becomes a positive 2. And then adding a negative is really like subtracting that 5. So 2 minus 5 is negative 3. and that does equal the negative 3 we have on the other side. So checking the second equation, then we have a negative 2 again, plus 3 times negative 5. So this is going to become positive 2 minus 15, which does equal negative 13. So this one is a solution to the system. Okay. So once you know how to check your solution, we can then go ahead and look through how do we find our solution on the graph. So if we use our graph to graph the two equations, so the first equation was 2x plus y equals 4. The second equation here is 3x minus 5y equals 6. And they're already showing them graphed on the coordinate plane for us. But you can see that the first equation and the second equation are intersecting in this point here, which is labeled as 2, 0. So again, you want to look for that point of intersection. Where are those two lines crossing? And then we need to check it and make sure that that solution works for both. So for example, if I'm checking the first equation, 2 times 2 plus 0 equals 4, I get 4 plus 0 equals 4, which clearly works. Now when I go to check my second equation, I have 3 times 2 minus 5 times 0. And again, that also works. So that confirmed that, yes, I must have graphed these correctly because they intersected at the one point that is a solution for both equations. Okay, so let's look at these graphs and identify the solution and check it. So looking at this picture, right, we want to find what the graph is here. So it looks like they're crossing right here at this point. So going along your x-axis, it looks like it's going at the 3. And then you go down 1, 2, 3, 4, 5. So make sure because we went down, you're doing negative 5. So this is what we're going to use for our x and our y to check our solutions. So I'm going to check in the first equation. So I'd have to do 3 minus negative 5. Now remember, when you subtract a negative, it's really addition. And 3 plus 5 does equal 8. So that is correct. Now when we go to do the next one, I'm going to do the second equation here. I have 3 plus negative 5, which is really like subtracting 5. And that does equal negative 2. So we must have graphed these correctly because the solution that we've identified works for both. Okay, so now let's check the next one. Okay, so we want to identify that point where they're going to intersect, which is right here. So going along your x-axis first, we had to go to the left to negative 1, and then we're going up 1, 2, 3, 4. So this is the solution that we think it is. So I'm going to put it into the first equation. 5 times negative 1 minus 4 equals negative 9. That gives me negative 5 minus 4 equals negative 9, which makes sense. Then I'm going to go check the second one. Now this time be careful, the y was first, so it's 4 plus 2 times x, which is negative 1, equals 2. So 4 minus 2 equals 2, which of course that works. All right, so now that we know how to identify our solution and how to check our solution, let's go into the graphing. So I'm actually going to move forward to example 3. So now we're actually going to graph them. So remember, the first thing that you need to do a graph is get into y equals mx plus b form. You want to do that first for each, then graph the equation, and then find the solution like we just did, and then check the solution. Okay. So getting our equations into y equals mx plus b. So let's take a look at equation 1. X minus 3y equals 2. If we want to get this y value by itself, we need to move the x to the other side by either adding or subtracting. And it's always going to be the inverse operation. So in this case, I'm going to subtract x from each side. So now I still have a negative in front of that 3y, so don't forget about that. Now over here, you could write 2 minus x, but the slope-intercept form always has the x term coming before the constant, so it's a good idea to get in the habit of writing it in that order. So negative x plus 2. Now we would want to finish dividing by whatever is being multiplied to that y value. In this case, it's a negative 3. So we're left with y equals, now here we have a negative and a negative, so they're going to cancel out, and it's just going to be 1/3 x minus 2/3. Okay, now if I go to do my second equation, this one here, I have negative 5x plus y equals 4. My y is pretty much already by itself. We just have to move this x term to the other side using that inverse operation of addition. So now I have y equals 5x plus 4. Now, if you remember how to graph equations, typically you want to find your m, which is the number in front of the x, and then your b, which is the number that's adding or subtracting to the end. So in the first equation, it's the 1/3 for the m and the negative 2/3 for the b. In this equation over here, your m, or your slope, is 5, and your b is 4. Okay, so the variables that we talk about, mx plus b, I always say the b sort of is for the word begin. Where do you begin? And we know it's the y-intercept, so somewhere on the y-axis we have to begin at negative 2/3. Now this one's a little tricky because it's a fraction. So negative 2/3, if I'm looking at my graph, it's going to be almost to the negative 1, just 2/3 of the way down, not quite the whole way. Now my slope, remember, is rise over run, so it's 1/3. So I'm going to rise 1 and run 3. You're always going to go to the right. So I'm rising up 1. Now I was down almost to the negative 1. So when I rise up 1, I'm going to go like almost like in between the 1 and the 0. But you want it like 1 box width above, and then you're going to go over 1, 2, 3. And then you go up 1 over 1, 2, 3. Up 1 over 1, 2, 3, like that. Now you could go down and to the left. So if you do both opposite directions, instead of going up to the right, you go down to the left, it'll just continue to make points on the same line in the other direction. Now to do the second equation, this here, our slope is a 5, which means it's really 5 over 1. And we're going to begin at the 4 this time. So I'm going to begin at my 4 on the y-axis, and I'm going to move or rise 5, run 1. So 1, 2, 3, 4, 5, run 1. I'm sort of out of space, so instead I'm going to go down to the left. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. All right, and so it looks something like this. And if you do your lines really nice and straight, you usually can kind of see where that point of intersection is. So it looks to me like it's at negative 1, negative 1. Now the only way for us to know for sure if this is correct is to plug it in. So if you remember when we talked about checking, right? So if I want to check this solution here, and I'm just going to try to make this a little bit smaller here. Now, you can check the originals, the form that they're in. You can also check these where we got the y by itself. I always think it's a good idea to check the original though, because what if you made a mistake when you're getting them in the slope-intercept form? So if I go to check my first one here, equation 1, I have to put a negative 1 in for x and a negative 1 in for y. So that becomes negative 1 plus 3 equals 2, and that works. And then I'm going to check the second equation, negative 5 times negative 1 for x plus negative 1 for y equals 4. And that's going to become 5 minus 1, which does equal 4. So this is the correct solution. Okay, let's try a couple more. All right, now this one's already set up for us in y equals mx plus b, just to make it nice and easy for us. So the first one, okay, our slope, remember, is always the number in front of the x. So in this case, it's positive 3, which I could put over 1. And I don't see a y-intercept there, which means it's actually 0. So I'm going to begin at the origin, or 0. I'm going to move or rise up 3 and run 1. So this is what the equation is going to look like, or the line, the graph is going to look like for that one. Now when I go to do the second one, my slope is 4, which I could put as a fraction to write over 1. And my y-intercept, or b value, is negative 1. So I'm going to begin at the negative 1. And I'm going to move or rise 4, 1, 2, 3, 4, over 1. Now this one worked out kind of nicely because the dots lined up, so you can actually see that they both ended up on this one point here, which I believe is 1, 3. So it looks as if 1, 3 is the solution. The only way for me to know is to check it, right? So 3 equals 3 times 1. That works. Now I'm going to check it for the other one, putting the 3 in for the y, 1 in for the x. So 3 equals 4 minus 1. That is true as well. All right, then the next one. So this time I have to get my y by itself. So I have 2x plus y equals negative 4. I'm going to subtract my 2x over. We want to get that y by itself. So we have y equals negative 2x minus 4. So that is our first equation. Now the second equation, right here, x minus y equals negative 8. Again, moving the x over, using that inverse operation. Just be careful, there's still a negative in front of that y, which is really a negative 1. So now I have to divide everything by negative 1 to get the y completely alone. The negatives cancel out here, so I'm left with x, and the negatives cancel out there, so I'm left with a positive 8. Okay, so graphing this one, I'm going to begin at the negative 4, and then I'm going to move negative 2 over 1. So negative 4. Now these boxes are going by 2s, so my negative 4 is going to be right about there. And then I'm going to move down 2 to the right 1. So down 2 to the right 1. Now you could go by boxes, or you can actually go by numbers. Either way would work, since the x and the y-axis are both labeled with the same increment. I can also do the exact opposite. Instead of going down to the right and go up to the left, and that will continue points on the same line, just so that I can kind of extend it across my coordinate plane. Okay, second graph, my slope is a 1 here, and my b, or y-intercept, is 8. So here's my y-intercept, and then I'm going to go up 1 to the right 1, or I could go down and to the left. So now at this point, you should be able to see where they're intersecting. It looks like negative 4 and positive 4 is our answer here. So the only way we know is to check it, right? So if I put in the 4 for the, I'm going to just do this original problem here. So it's 2 times negative 4 plus 4 equals negative 4. A lot of 4s there. Negative 8 plus 4 equals negative 4. That does work out there. And then I'm going to check my original one here. So x is negative 4 minus y, which is 4, and that does equal negative 8. So it looks like we have a good solution for that one. All right, let's move on to another one. All right, so first equation, I have negative 3x minus y equals negative 1, and I want to get the y by itself. So moving the x term to the other side, using that inverse operation of addition. And don't forget, you still have a negative in front of that y. The negative doesn't go away until you divide everything by that negative 1. So now I have y equals negative 3x plus 1 as the equation for my first line. If I go to graph this, my y-intercept is this positive 1. My slope is the negative 3, so down 3 to the right 1, down 3 to the right 1. Okay, the second equation, I'm going to get the y by itself, moving the x over to the other side, opposite. So I have 4y equals negative 2x minus 16. Let's get the y completely alone by dividing everything by the 4. Y equals negative 1/2. Make sure you simplify your 2/4 minus 4. I'm going to begin at the y-intercept, which is negative 4. I'm going to move negative 1 over 2, which is rising negative 1, which means you're going down, and then 2 to the right. So down 1 to the right, down 1 to the right, or you could go up and to the left. Okay. Now it looks like they're intersecting right here at this point, which is 2 and negative 5. So let's check it to make sure that 2, negative 5 is the solution. So 2 for my x, so I'd have negative 3 times 2 minus the negative 5 for my y. Negative 6 plus 5 does equal negative 1. Then checking my other equation, 2 times 2 for x plus 4 times negative 5 for y. This is 4 minus 20, which does equal negative 16. So it looks like we have been successful once again. All right, so I think at this point we've done enough of those to get an idea. So let's go over a couple word problems and see how this is applied. All right, so you've bought 12 2-liter bottles of Pepsi and Sprite for a school dance, so 12 total. The Pepsi was on sale for $2 per 2-liter bottle, or per liter bottle, I'm sorry, and the Sprite was on sale for $3 per bottle. You spent $30. So notice that we have a bunch of numbers, and it's also a little confusing because we're talking about 2-liter bottles and things like that. But basically, we have two things that we're comparing here. We're talking about the cost, and we're also talking about the quantity. So we have a situation where we spent, X amount on one item, Y amount on another item, and we have a total cost. And we also bought a specific number of the two different items. So when we do this, we're going to have two equations. One is the cost equation, which involves the $3 amounts. And the other one is going to be the quantity equation, which is going to involve amounts that are not dollars. So in this case, we have Pepsi plus Sprite equals your total. Now, if I want to do my quantity equation, I have, let's say, X amount of Pepsi plus Y Sprites, and we know the total was 12. So that would be my quantity equation. How many of this object plus how many of the other object equals the total that was given to you. Now, the cost equation, actually, let me give a little space there. Is, okay, so we're still doing Pepsi plus Sprite equals the total, but we're looking for the dollar amounts now. So how much did the Pepsi cost us? Well, it cost us $2 per bottle, and we bought X bottles. And how about the Sprite? Well, the Sprite cost us $3 a bottle, and we bought Y of those, and we know the total that we spent was 30. Okay, so they're both set up in standard form, and X plus a Y equals some total. Now we're going to graph them, but in order to graph them, we need to get them in slope-intercept form. That's one option. The other option is you could find your intercept. So when I graph one like this is how I would like to do it. So if you put a 0 in for X, what does your Y have to be? Okay, y would have to be 12, right? So 0, 12 is one of the points on this graph. Now, if you're doing it the other way, what if you had a 0 for y? Then what would your x be? Well, then that would be 12. So this is one way to graph. Just put a 0 in for x, find the y. Put the 0 in for y, find the x, and you have 2 points. And for these types of situations, it works very nicely because now you have 2 nice, easy points, 0, 12, 12, 0. So 0, 12 is going to be right here, and 12, 0. Or sorry, this is 0, 12, and this is 12, 0. I'm sorry. And then you can just draw the straightest line you possibly can between those 2 points. And it's a little hard on my screen, so bear with me. Now, when you're doing this for the other equation, again, you want to put in a 0 for the x and solve for y. So that's going to cancel that out. You're left with 3y equals 30. Divide by 3, y equals 10. So that point is 0, 10. Then you're going to do the same thing again, putting the 0 in for y, which cancels that out. Divide by 2, and you get x equals 15. So your other point is 15, 0. Going to the 15, and the 0 is right there. 0 and 10 is right there. And now I'm going to try to graph a straight line. It's kind of hard. If you have a ruler, it'd be really advantageous in this situation. All right, now, because I didn't draw my red so straight, it's going to be a little tricky to see where they cross, okay? So I'm going to have to kind of guesstimate. I'm going to think this red line here is a little bit off. I think it's more like that. All right. So if you have a ruler, this works out really nicely, and you can kind of see where they cross. So if my line were straighter, I would guess it's right about there, which is 6, 6. Okay, now another way you could do this, of course, you can always get them in y equals mx plus b like we were doing. So if I were to do this equation here in y equals mx plus b, the advantage to this would be that I would have more points on my graph. And then you would be able to a little bit more easily see where they're going to cross. So this would be negative x minus 12. All right, wait, I messed up something there. Hold on. Oops, sorry about that. All right, we didn't have to do that part. I copied something wrong. Okay. Now, if we want to check this, we know 6 plus 6 equals 12. And then, of course, over here, 2 times 6 is 12, 3 times 6 is 18, and that does equal 30. All right, so you're selling tickets for a high school basketball game. Student tickets cost $4. General admission costs $6. You sell $350 and collect $1,800. So if we do our quantity equation, that's the short, easy one. You have X amount plus Y amount equals your total, right? So in this case, we have student tickets plus general admission tickets equals your total, right? So we bought X amount of student tickets, Y amount of general admission, and we know that there's 350 total. Now for your cost, you're just going to put the dollar amounts in front. So student tickets cost $4, so that would be 4X. General admission tickets cost 6, so that would be 6Y. And this time it's going to equal the total dollar amount. Okay. Now, if you do the intercept method like I showed you on the last problem, you will have 1 point on your x-axis, 1 on your y, and you just connect them. The advantage to it is quick and easy, and you always have a point on each axis, but you really need a ruler or a straight edge to draw your lines so that so it's not crooked, and you can really see where they cross, because as you could see, it was a little hard for us to identify that intersection. So this time I'm going to just do it by y equals mx plus b, so you can see the difference. So this time I'm going to subtract my x. y equals negative x plus 350. So this means my y-intercept is 350, and my slope is -1, which means I'm going to go down 1 and over 1. And as long as my labels or increments are the same, I can just count by boxes, because these boxes is representing 25, and you wouldn't be able to actually do it by the numbers. Okay, so this is my line. It's a little bit easier now to draw it straighter without a ruler, and you can see all those points that are going to be exactly on it. Okay, now the other one, I'm going to subtract 4x. 6y equals negative 4x plus 1800. Divide everything by 6. And we end up with y equals, it's going to be negative 2/3 x if you simplify that fraction, plus 300. So now this time I'm going to go up to 300, and then I'm going to go down 2 over 3. Let's say you forgot to simplify the 4 6, and you went down 4 over 6, you'd still get the same line. So down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3. So you can see this time it was a little bit easier to see that point that landed on both, because when we do that rise over run, we make so many points across. So it's a little easier to identify that point of intersection, which looks like it's 150 and 200. Now again, when we're doing these problems, 150 what? Student tickets, because that's what our X represented, and 200 general. Now does this make sense? We're going to check it. Does 150 plus 200 equal 350? Yes. Now what if you put the money in? 150 times 4 would be 600. 200 times 6 would be 1200, and that does equal 1800, so we checked it. And just to go back and check the previous question, this, make sure you have labels. So this was 6 Pepsi and 6 Sprite. All right, now this question's set up a little differently, because this time it's not adding up two things and getting a total, it's comparing two different people. So you have $10 in your piggy bank and you're adding $2 a week, you're saving, so you're increasing your money. Your sister, on the other hand, had $40, but she's spending $4 a week. After how many weeks will you both have the same amount? So you have your situation, right? So we'll do you, and then you have your sister. All right, so this time you're each going to have an equation, but you're each going to have a y equals equation, because you're trying to figure out the total that you have, which is y, and then the total your sister has. So what do you have? You have $10 and you're adding 2 per week, so 2x. Your sister, on the other hand, her total is $40 minus 4x, because she's subtracting 4 per week. Now, the good news is these are basically already in slope-intercept form if you switch out the order there. Negative 4x, though, plus 40 for her. So we can graph them. So go to 10. Now, 10 is in between the 8 and the 12 here. And then we're going to go up 2 over 1. So up 2. Now, if I'm starting in the middle of the box, I got to go to the middle of the box. So up 1, 2, and then over 1. Up 1, 2, over 1, up 1, 2, over 1, like that. The sister, on the other hand, she's starting at 40, which is off the grid somewhere, right? So this would be, I think it'd be right around there. I guess I didn't make my graph big enough. And then we're going to go down 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And it's going down. Now, the point where they crossed, it's not exactly on the corner of the square. So we're going to have to estimate what we think that value is. So going on my x-axis, it looks like it's kind of like right around here, which I feel like is a 5 maybe. And then over here is a 20. So I'm going to try that and see if that works. So if I put in a 20 for my y and I do 10 plus 2 times 5, does that work? Yeah, let's try it for the other one. If I put in the 20 for my y, 40 minus 4 times 5, that works as well. So that means in 5 weeks, you're both going to have $20 because you're trying to find out when your pattern of money and your saving is going to cross paths with your sister's money of pattern of spending and when you'll have about the same amount. All right, so you can see the different ways we can graph these, the different methods we can use to help us kind of find when things are going to match up, or if we're, buying two different products and we want to know the different options of when it will work out to the amount of money that we have and the quantity that's sold or whatnot. And that's it.